Let's take a look at number 1, and this is for section 1.2 practice work. So the title on the handout is Cycle 1, Day 2 in Class, Probability Continued Practice Work, and we're looking at Part A, Contingency Tables and Tree Diagrams. So let's work through this together. First of all, for question 1A, we are asked to calculate the probability that a randomly selected student is male. So probability of being male, favorable outcome goes on top. Our favorable outcome is being male, and in total, there are 11 male students. So 11 is going to be our top number, and our bottom number is the total number of students, which is 26. So we'll plug that in, and then we can convert to a percentage. I don't think you need to for the answer key, but just for habit, 11 out of 26 gives us 42.3%. Next up, question B, calculate the probability that a randomly selected male student is in cohort B. So we are limiting ourselves to the category of being male. So we're going to get our values from that row of the table. So probability of a student being in cohort B2, given that they are male, so it's kind of a conditional probability, but we can still just calculate it simply, is that there are 6 male students. We want to know how many male students of the male students are in cohort B2. So there are 5 male students in cohort B2 divided by the total number of male students, which is 11. And so our answer is 5 over 11. And if we convert that into a decimal or a percentage, we're going to get 45.45, or we'll just round to 45.5%. Next up, question C. Which cohort is more likely to randomly select a female student which cohort am I more likely to randomly select a female student if I select one student from each cohort? So what we're going to do is we are going to figure out the probability of a student being a female for each given cohort. I'm going to start with cohort A. The probability of being female. Given that we've selected cohort A. So within cohort A, we have 8 female students out of 14 students. So that's going to give us a percentage of 8 divided by 14 is 57.1%. For cohort B, we're finding the probability of being female given that they are in cohort B. So within cohort B, we're going to look at the values. We see there are 7 female students out of a total of 12. As a percent, that is going to be 58.3%. And I don't have room to write my concluding statement, so I'm just going to say it verbally. If I select a student randomly from each cohort, the probability of them being female is higher for cohort B, given that the probability of choosing a female student from cohort B is 58.3 compared with 57.1 for cohort A. Question D is a little bit more involved, and we're going to need to make a tree diagram. So we're going to make that as we go and then use it to answer the question being asked. This is one of those probability tree diagrams, so we need to include the probabilities as we write. Let's take a look. For question D, if I select 2 students at random, what is the probability that they are both male? So there's 2 students being chosen, student 1 and 2, and let's think about our options. The student can be male or female, and the second student can also be male or female. So these are our possible outcomes. Now let's take a look at the contingency table and figure out what are the probabilities for each case. For being male, there are a total of 26 students and 11 are male. So the probability of being male is 11 out of 26. And conversely, the probability for being female, there are 15 students left, so 15 out of 26. Now let's consider the first option. So we're going to kind of go along the first branch that we see here. So we're going to go along here. What is the probability of being male in the second case if the first student was already male? So we've already chosen one student, so we're not choosing out of 26 students anymore. We're choosing out of 25. Let's get in the correct pen mode here. And I'm going to change my color too as well. All right, so there are no longer 26 students. We've already selected one out. There are 25 students. And we've also reduced the number of males. There were 11. In this case, we've already taken one out, so it's 10. So this is a conditional probability. It depends on what happened during the first event when we chose the first student. The number of females has not changed. It's still 15, but the total number of students has changed, so it's 15 out of 25. Next, if the first student we chose was female, there are still 11 males left to be selected, but only a total of 25 students left. And finally, on the bottom, if the first student was female, we have one less female student left. It's going to be 14 out of, we've reduced our overall population by 1, so out of 25. Now let's take a look at actually doing our calculation. So this is an AND calculation, so the probability of the first student being male and the second student being male. Remember, when we see AND, that's an indication that we're going to need to use the product rule, and these are dependent events. They're not mutually exclusive. Both students can be male, but the probability of the second student being male or female depends on what happened during the first event. So we're going to have equals probability of male given that the first student was two aspects we need to consider. The probability that the first student was male, and means we're going to multiply the probability that the second student is male given that the first student was male. And we have those values from our tree diagram, so let's take a look. Probability of the first student being male is 11 over 26. The probability of the second student being male, given that the first student was male, is 10 over 25. So let's plug in those values. Probability of being male in general is 11 out of 26 times probability of being male, given that the other student selected was male, is 10 over 25. And let's calculate. 11 over 26 times 10 over 25. In fraction form, that's going to give us 11 out of 65. Or if we wanted to put it in percentage, it would be 16.9%. Our final question is kind of similar to the previous one in that we're going to need to make a probability tree diagram. And it's also similar to the kind of multi-layer question we had in class with Nisa Cat needing to go to the vet. Let's take a look. If I select two students at random, what is the probability they are both from the same cohort? Let's take a look at our options. So first of all, we're going to choose our students, 1 and 2. And the values we're looking at, the outcomes we're looking at, are which cohort they come from. So cohort A or B, we're going to split A and B and split A and B. And looking at our contingency table, we can find the probability of each event. So let's scroll back up and let's take a look. The probability of being from cohort A is 14 out of 26. So what am I going to label that? 14 out of 26. And conversely, being from cohort B is going to be 12 out of 26. We can scroll back up and look, or based on how many students are left to be selected out of 26, we can figure that out right away. And we don't really need to scroll up again. We do have enough information here. Next, we're looking at what is the probability of being in cohort A, given that the first student was already in cohort A. Well, what's changed? We know there's one less student left from cohort A to be selected, so there's only 13. And out of the 26 students that were there to be chosen from, there are only 25 left. So it's going to be out of 25. The number of students in cohort B hasn't changed, so it's still 12. And the bottom number is 25. Or we can think about every branch coming off the node has to add to 100%. We've already had 13 out of 25, so in order to fill that back up to 100%, it's going to be 12 out of 25. Whichever way you want to think about it is fine. Oops, that erased the whole thing. 12 out of 25. Next, on the bottom, if our first student chosen was from cohort B, then all the cohort A students are still left. There's still 14 left, but our total population is only 25. And finally, if the first student chosen was from cohort B, there are only 11 cohort B students left, and out of 25. All right, we have all our values. Let's set up our problem now. So I want to find the probability of a student being from AA or BB. It's an OR problem, so these are mutually exclusive events, and when we see that, we are going to be adding. OR means add, and means multiply. So we're going to add, so it's going to be the probability of AA plus the probability of BB. Now let's break that down a little further. The probability AA, actually I'm going to rewrite this a little bit. Actually, that's fine. We can work with it that way. So probability of AA means the first student was from A and the second student was from A, or plus probability of being from B and the next student was from B. And the probability of the second student being from A depends on the first student being from A or not. The outcome of the first event is going to influence the outcome of the second event. So these are dependent probabilities. So we're going to be multiplying and having conditional probabilities. So let's take a look at the next layer. Probability of being from A and A is equal to probability from A times probability of A given that it was A in the first place, or our other options, so plus probability of being from B and B. I guess I didn't change anything on this line. That's fine. I just wrote a little bit of extra. So is probability of being from B multiplied by the probability from B given that the first selection was also from B. All right, we have those values, so let's find them from our tree diagram. Probability of being from cohort A is 14 out of 26. Probability of being from cohort A, given that the first student was from cohort A, is given right here. So that's the value that we're going to carry over. So it's going to be 13 out of 25 plus probability of our initial student being from B, given in our tree diagram, is 12 over 26 times probability of being from B, given that the first student was from B, is 11 out of 25. And let's multiply and let's see what we get. So I'm going to multiply these values all on my calculator. So 14 over 26 times 13 over 25 plus 12 over 26 times 11 over 25 is going to give me as a fraction 157 over 325, or as a fraction 48.3, oh, sorry, as a percentage 48.3%. And let's just double check, did we actually successfully answer the question? What is the probability both are from the same cohort? We should have a concluding statement, which I forgot to do for D, but therefore, if two students are selected at random, the probability of both being from the same cohort, so either AA or BB, is And I'll just leave it as a fraction because that's what the answer key does, although it doesn't really matter. 157 over 325.